Example 1c. Simplify the complex fraction 2 over m squared minus 3 over m, all divided by 2 over 5m squared minus 1 over 3m. All right, now this is even more complicated than the previous complex fraction. Notice both the numerator and the denominator need to be simplified before we can go on. So we need to rewrite our numerator into a single fraction. Let's start. We have 2 over m squared minus 3 over m. To combine these two rational expressions, we need a common denominator. Notice we have m squared here and m here. The common denominator is simply m squared. So what do we need to do to change this fraction to have an m squared? We need to multiply by a factor of m in the denominator and consequently the numerator. Now we have m squared and m squared, so we can combine. Our common denominator is m squared and our numerator is simply 2 minus 3m. Those are not like terms, so we cannot take and subtract them, and we stop right here. This is as far as our numerator can go for now. Now we take a look at our denominator. Our denominator is 2 over 5m squared minus 1 over 3m. Again, in order to add these, we need to get common denominators. This one's a little trickier. It's not too bad. Notice, what's our LCD this time? Our LCD is composed of a factor of 5, a factor of 3, and again, m squared, 2 m's. So that means our LCD is actually 15m squared. We need to rewrite both fractions to have the common denominator of 15m squared. Now, what do we need to multiply by to get that achieved? Right here, to get 15, we need to multiply the 5 by a 3. So that means we'll also have to multiply our numerator by a 3. The m squared matches, so that's it. The new numerator becomes 6. Now we want to change the 3m to 15m squared, so we need to multiply the 3 by a 5 to get 15, 3 times 5. If we multiply the bottom by 5, we need to multiply the top by 5. And to get m squared, we need to multiply this m by another m. We have to do it both to the bottom and the top. That means this numerator is now 5m. We can now combine, because these are like rational expressions. The denominator will be 15m squared, and our numerator will be 6 minus 5m. All right, so now we have a single fraction for our numerator and a single fraction for our denominator. So let's rewrite our complex fraction to have these new simplified fractions. So our numerator becomes 2 minus 3m over m squared, and our denominator becomes 6 minus 5m over 15m squared. What do we do now? Well, now we divide. Top fraction divided by bottom fraction. And how do we divide fractions? Well, we invert the second and multiply. So let's rewrite our top fraction, 2 minus 3m over m squared. And let's invert that bottom fraction. So 15m squared goes on top, and 6 minus 5m goes on the bottom. First thing is to factor. Is there anything that can factor here? Well, 2 minus 3m, nothing factors out. 6 minus 5m, nothing factors from here. 15, well, we could factor that down, but there's nothing to cancel with it. So all we can do and all we can see that will cancel is notice we have an m squared here and an m squared here. So let's go right ahead and let's just cancel those m squareds. None of the other factors will cancel, so we combine by multiplying. In the numerator, we have 15 times 2 minus 3m, and in the denominator, we simply have 6 minus 5m. We have now simplified our complex fraction. If you like, you can multiply out the top and rewrite this as 30 minus 45m all over 6 minus 5m. And for those adventurous ones that might discover or see that actually you could factor a -1 out of numerator and denominator and cancel it, you could also rewrite this as the expression 45m minus 30 over 5m minus 6 if you happen to like positive coefficients on your variables. Those are all the same, and they all represent the simplified form of this complex rational expression. This brings us to our last example. Simplify the complex fraction. Example 1D, 1 over y minus 1/6 divided by y minus 36 over y. In this complex fraction, both our numerator and denominators need to be simplified first before we can divide. So we want to combine 1 over y and 1/6. We have 1 over y minus 1/6. The least common denominator for these two rational expressions is the expression that contains the factor of 6 and the factor of y. In other words, the least common denominator is simply 6y. We want to change both of these fractions to have that denominator of 6y. So what is it that we need to multiply by? Well, in the first fraction we have a y. What's missing is the factor of 6. So we need to multiply both denominator and numerator by 6. 6 times 1 is 6. There's our new fraction. The second fraction, we're missing a factor of y in the denominator. Whatever we do to the bottom, we do to the top, and so that means the numerator is 1 times y, or just y. Combining these fractions, they have like denominators. That denominator is 6y, and the numerator simply becomes 6 minus y. So, our numerator for our complex fraction is 6 minus y over 6y. Let's now look at the denominator of our complex fraction. Y minus 36 over y. Now, to put these two expressions together, we want to rewrite our first term as a fraction. That is, we want to put y over the number 1. Now we have two fractions. The least common denominator is just 1 times y, or y. So we want to rewrite each fraction to have that least common denominator of y. We need to multiply the first fraction by y. Y times 1 will give us y. If we do it to the bottom, we do it to the top, and so that means that our numerator is simply y squared. The second fraction already has a denominator of y, so we don't need to change the numerator. We can keep it as 36. And combining, our denominator is y, and our numerator is simply y squared minus 36. We've now taken both our numerator and denominator of the complex fraction and rewritten them into simpler fractions. Let's replace. The numerator is 6 minus y over 6y. The denominator is y squared minus 36 over y. How do we simplify a complex fraction when we have a simple fraction on top and the bottom? Well, we simply divide. That is, we take the numerator divided by the denominator. That's the same thing as saying 6 minus y over 6y times the reciprocal of the denominator, y over y squared minus 36. We proceed to factor. Now, 6 minus y, That in itself, there's nothing you can pull out unless you observe and think ahead that perhaps we're going to want to pull out this -1 in front of the y. Let me rewrite this. 6 minus y is the same thing as -y plus 6. I'll just keep it like that for a second. 6y, I'll stay as 6y. Y will stay as y, and y squared minus 36 is a difference of squares. Y squared minus 36 is y minus 6 times y plus 6. Now do you see why it's important? If we factor out the -1, remember this expression turns into y minus 6 with a -1 in front. So that's what we're going to do. We're going to factor out a -1. We've seen this pattern before. We take out a -1 and we're left with y minus 6. Double check, -1 times y is -y. -1 times -6 is positive 6. Over 6y times y over y minus 6 times y plus 6. Writing out your factors that way, it becomes clear things that will cancel. The y minus 6 cancels from numerator and denominator. The y cancels from numerator and denominator. Nothing else will cancel, so we combine by multiplying. Our numerator is -1 times 1 times 1, or just -1. Our denominator is 6 times y plus 6. That's it. You can leave your expression like that. Or, if you prefer, you can multiply out your denominator. -1 over 6y plus 36. These represent the simplified form of our original complex fraction.